I'm very happy to be here. Actually, I'm not even feeling out of the country right now because that's usual for me. Snow like this, it's like no big deal. I thought I would be lucky and get something else than KubeCon, but it looks like snow is following me all over the place. So let's talk about Helm in a Ubisoft context. I work for Ubisoft. Ubisoft is a big company. It's a company that has about 3,000, actually close to 10,000 employees, 3,000 in Montreal. I'll talk about why we're using Helm, what were the decisions and what problem Helm solves for us, how we're using it, and eventually where we're heading with Helm and where we would like Helm to head forward. So let's start with the why. We have multiple game productions at Ubisoft. Actually, that's the three steps that we want to talk. I'm going to talk about multiple game productions, multiple clusters, and then the sharing between all of this. So we have multiple game productions at Ubisoft. We have over 30 studios that were working on games. Not all of them are producing games, but most of them are contributing to games. There are several game productions per studio, so we have lots of people working on that. So that makes it to something like, last count was over 300 people being directly involved on online production, be it operators, developers, or content creators. Each production will actually have multiple clusters. So we're going to have clusters that are internal, that are on GKE. We're actually moving eventually to Amazon as well. So we're actually targeting a lot of different types of deployments. And the first focus that we have, because we're working first with AAA content, for those who are not quite aware, all the big games that Ubisoft are developing are EA, or if you have thousands and hundreds of thousands of users, these are called AAA games, and these are major games that are involving up to 500 or 600 people working on that game. That's where we're targeting the first implementation of our new platform. So these games have the throughput and the power to actually operate their own cluster. So we need to deliver stuff for these guys to actually operate what they want to operate. We can't just say we have a close pass that we're using and say, oh, we're going to handle it by a centralized team. We need to provide stuff for people to actually operate their clusters. So that leads us to sharing. We want to share, and we have a team that is doing the core of the business of actually trying to do the platform. But then we need to share all that stuff, and that's where Helm comes in, because we want to make sure that we can control what we're sharing, that we can publish stuff, and we can make it so that people can use it. We also want to eventually have, and that's really hard to do because game production are focused on making games, not making stuff that other people can use. But we want to have games to make sure that they can provide some charts or some way of sharing information between all the games. So if you write a cool microservice that could be used on another game, we should actually be able to do that. So we have to make it easier. And also, as I was saying, is that we need to make sure that it's easy for these people to actually deploy stuff, because if we can't do that, and it's going to be a really hard sell. If we tell them, well, fork my manifest over here and just replace all values you want to replace, that doesn't fly for us. So this is why we're using Helm. Helm will actually help us share, help us standardize the deployments, help us just have a standard way of talking and saying, this is how we want to do our stuff. The how part, I'm going to talk about what we're doing with charts, what we're doing with assemblies or umbrella chart, depending on the vocabulary we're using, and what our struggles or what we're doing with the hosting and the deployment of the charts, how we're handling that. It's going to be fairly high level because I don't want to go too deep in what we're actually really doing. And also Ubisoft is a fairly cautious company, so we're not going full-blown with everything. We're sort of targeting different production and trying to move forward and make sure that we're moving in the right way. And also one thing that you need to be aware of in gaming, if you talk about gaming, is that, and mostly that's probably a trait for most developers, that yes, they want to have something really simple. They want to have something that, oh, it just works out of the box. I have no problem. But I need to have all the knobs to tweak everything that needs to be tweaked at any time that I want to do it. So that's a really hard struggle for us, and we're trying to balance this by just moving forward and backward and forward and backward and doing some experimentations. So currently we have over 60 charts that are being published in our repo. We have over 1,000 versions of these charts, so we're publishing and doing continuous delivery. So we have a fairly, according to us, a fairly large pool of versions that we need to handle. The charts, the charts are basically solving some of these issues right now. It's really well, other than the actual what Helm is doing, so abstracting the values that we can actually have people reuse the values, we're also abstracting the logic of where the chart is going to be deployed. So we have some logic in the chart to say, if you're running on Minikube, that's way different than if you're running on GKE because of the resource pool, the way the ingress are set up, and a lot of stuff like that. So we do have lots of logic that internally will make it so that people can actually use it, because we're using Minikube quite heavily right now. And we want to make sure that the same chart can be deployed and you're not publishing 2, 3, 4 different flavor of charts. So that's something we're trying to do with our chart. Once we're doing that, we also need to have some documentation of the values. So there's a pretty standard way right now with the stable charts or incubator charts to have a table in the markdown to say these are the values that it can be changed. Now, if you change the value file, now you need to sync your markdown, and then that gets really tedious, and it's even more tedious if you're using assemblies that are referencing charts inside the charts. So we wrote some tools to actually just take the chart and then just output the value inside a markdown, so with all the default and the comments. So we can actually have a standard way of having all the information, and people don't need to go back and forth and say, oh, you haven't updated the documentation. Now, the next part, the other part of this is that once you try to consume charts, if you have charts that have lots of values, and the values are a lot of places with a lot of nesting, now it becomes really tedious to actually see, oh, did I put this value at the right place at the proper nesting, even though we're really highly efficient with YAML indenting. You always screw up at one point. So we wrote a tool as well. There's a plugin that will actually try to, as best as it can, just go and take your value file, go and check what the value files of the chart is, what is expected, treat it as a schema, and then come back with information saying, oh, you're missing this, or this hasn't been found, are you sure you want to do this? So we have a tool like that so that people that are consuming our chart can actually say and validate that the values are as good as they can be. So that's what we're doing with charts. Now, I did mention assemblies and umbrella charts. We went fairly deep into using assemblies in our case because our legacy system was a monolithic system where all the services were deployed at the same time, all the time, and it was working like this. So game productions were fairly comfortable having this as well. Now we have several levels of assemblies in our case. We don't have only one, so we have one that our central team is doing. That's an example of more or less what we're doing with our central team. These are all different charts. They're using as alias. We're pushing the boundaries with that. And it comes up to 16 charts or more or less that are bundled together. And then this is actually bundled inside another assembly, which is all the production they're using for their games and everything. So you can come up with something like 30 or something charts that are all bundled in one. And this is quite helpful for us, but at the same time, it's sort of a drawback for Helm. Right now, we're hitting some limits on Helm. We're also doing that for our telemetry stack, which is using Elasticsearch, Kibana, Prometheus, and other stuff. And that puts a really big toll on Tyler right now. So we do have some issues with that, but that's something we want to use for some of the parts. So now we're refining our system. We don't want to push that anymore for everybody. They're getting more comfortable saying, oh, we want to release services by themselves, not as a big unit. So it's going to be broken up for game production, but we still have the need for some of our internal, what we call stacks. The hosting, that's an interesting part that we had. At first, we started with the standard naive approach of having just one index YAML file at one place. But you've seen with all the versions that we have, we did hit some concurrency issues where it was really hard for us to just go and say, oh, we're going to update this index.yaml. And then you come back and you have somebody else that did the same thing at the same time as you thought you were doing it, and then you were missing some files. So we haven't seen that all that much, but we were really concerned that it was going on. So we wrote our own internal tool to actually host, but the performance worked really good. And eventually, while talking about it, we had Chart Museum come up on the map and said, well, that's exactly what we need. So we're not going to write it our own. We're going to go forward. So we've been contributing with two of my guys have been contributing in Chart Museum to make sure that we can make it work. So now we're hosting Chart Museum, and we're probably going to host multiple instances of Chart Museum for multiple productions to have all the segregation and stuff and give control to whoever. So we're just looking at stuff that is being done outside and just try to bring it back and make sure that we can use. So we're all really interested in what's going on outside. Deployment is something that we're actually experimenting with right now. So we have a straight GitLab CI type of thing. So we're pushing the charts, just doing a build, validating the chart with the YAML file linter and all that stuff. And then we had some custom scripts that were doing deployments. Now, what we've been doing so far lately is that because we have some limitation with Helm in terms of the versioning. So if you push new releases to Helm, it actually versions the release even though the release hasn't changed at all. And we're trying to do something where we can actually push multiple versions at the same time in one CI to treat a cluster as these are the releases of a one cluster. So with this, we actually went ahead and tried to analyze what we could do and what we could try to do, and then we came up with that we need to have some state that is controlled somewhere. And one tool that is doing that really greatly right now is Terraform, which we actually contributed to the Terraform Helm provider. So there's a provider for Terraform that can actually use Helm to deploy charts. So we're experimenting with that, trying to come up, and so far it's been pretty good. So we can actually have all of our charts inside, and whenever a chart changes, be it the value or anything like that, it will actually be updated by Terraform. But if it doesn't change, well, there's not even any call to Tyler or anything like that. So we just make sure that we don't put a hit on Tyler, because the version is one part, but there's also, if you push a chart that is really big, it still needs to go through all and everything, and then it takes a toll on Tyler that you don't need. But this doesn't do any reconciliation. So if you change your cluster, well, we're assuming that nobody's going to change our cluster. So our cluster are fully automated right now. There's nobody touching the cluster internally. Now the where part, where we're heading with Helm, or what we want to do, we're going to talk about usability, visibility, and the usage, and the internal usage that we're doing. Usability is mostly that right now we're hitting some, it's not big problems, but it's something that we want to work on. And we do have some problem with collaboration. And that's something that KSNet is addressing. Right now, it's really hard to say. Let's take an example. I want to monitor my service. I need a headless service inside Kubernetes. Now, this is a recipe for the telemetry team to say, this is how you're going to be monitored. So you need to have this annotation. You need to have this type of service. You need to have these labels, whatever you need to have. Now, right now, the only way to do that is to say, well, everybody that is writing chart, could you please do this? Now, that's a recipe. That's not a deliverable, sorry. And we want to have something that is deliverable, that could be versioned, could be obtained. So we want to have something closer to libraries. So could we publish something somewhere by the telemetry team saying, this is the way you're going to do it, just use this and don't care how it's being done. And that's something that Helm didn't address right now, and that we would like to see where we can go with. Also, composition is one thing, but that's being addressed by other stuff. But right now, we do have some charts that are, the way that charts are built is mostly that charts assume that they're going to be deployed by themselves. They don't really care that nobody else needs to be referencing them or stuff like that. So I do have an example where if I deploy a Postgres will actually name its services according to the release name. Now, my service that needs to address the Postgres by its side in an assembly, well, needs to know that it will be addressed by this type of schema to actually address the name. But I'd like to be able to inject information saying, by the way, my name for your Postgres would be something like this, and I don't really care. So it's more of how do you make everything work together, and it works fine. And also an issue that I've opened in, that is currently open in Helm is to have some native way of having in Helm environment selectors or some reflection of where you're running in. So that would be really nice so that we don't need to come up with these. This is a scheme where you need to tell the user needs to specify the cluster type that it's running in, which actually should be auto-detected internally. Then we can operate on that and maybe have it something that is slightly better and more generic for everybody. Visibility, that's a goal for us right now. We want to increase sharing. We want to make sure that people know and can discover things. So we're really looking at monocular. We haven't had time to tackle that, and that wasn't our focus, but it's becoming more and more of a focus. So that's something that's really interesting for us, is how do we discover charts, how we make sure that we can actually find them and also get information. So I think that's pretty much covered, but we need to go into these directions. And the usage, I did touch on that. We do have, and right now I'm just before leaving, like about 2 days ago, one of my guys was coming and saying, I want to remove Helm for everybody and all that stuff, because he was hitting problems with several bugs at the same time. So he went from 2.7 to 2.8 to 2.8.1 to 2.6 because different bugs were affecting different issues. And he was really on the side that we should rewrite everything and do it ourselves, which I don't quite agree. But we need to actually come back and have make sure that we actually have some stability and some stuff, because some of the issues are quite deep, and then some of this stuff is a bit tricky to do. But we did come up with some solutions. But right now it's something where we're having a look at Helm and saying, well, does it still fit the bill for what we're doing? And then are we hitting more and more problems? Because it looks like in the latest version, and that's for different reasons, we did have some regression on some parts. Now, we do have some really big charts. We do have some really big stuff that is pushing the boundaries of some of that of Helm. So we're trying to pull back for some of these stuff and then say, maybe we're going to be better if we do something more a bit simpler on our side. But we're keeping an eye on this. We're talking also, that's a minor issue, but version compatibility is mostly the client and server. So at sometimes we don't feel that. No, we do have, as you've seen, for some people, some operators, they're working on different clusters with different version of Helm, and they need to switch back and forth for the client. And we don't see a really good reason for 2.7 not to be compatible with 2.8, and we're getting warned and say, no, you can't. And then it's sort of a burden for us to actually go back and forth. And then that's probably needs to be clear and why it's doing this, and actually why are we actually doing this? Because sometimes the protocol hasn't changed, but the client version has changed. But then you're forced to update your client, but you don't really need to. And then also we're looking into, we have a fairly basic CI/CD on our side, but we want to make it more and more robust. So we're looking at the automation integration CI/CD with different products, Spinnaker, Weavework, and all these good tools, and see how they can mesh up with Helm or not, or see how it's doing. Also looking at KSNet and see where it's heading and what we can do with that. And that's one of the reasons why I'm here today, is to actually go and have some information on where we're heading and maybe try to influence some of the issues that we're doing. So that's pretty much for my talk. If anybody has any question or anything they want to go deeper, you can ask a question right now, or you can come and see me. I'll be more than glad to actually talk about anything else, or games. I know that people are coming to me and say, oh my God, the way Ubisoft is so cool. I'm sorry, I missed the last part.
Sorry. Is there a relationship between the versions of the Helm charts and the versions of your services, of each service?
Right now there is. So the release, not the release, the version of the Helm chart is the version of our services. We do have, for some teams, they're using an internal framework that will actually do the container, the charts, and release everything every time. And it's the same version for everything, so it's being pushed, and the service is at that version. Now, that's the version of the chart and the service. It's not the version of the API. We do have a strong distinction of this to have the version, but that, yes, it's the same version.
That's sort of what I expected, but I just wanted to see. Yeah. Thanks.
How are you managing the cluster type logic?
Right now, it's fairly, well, we do have one entry value, one of the values that is the cluster type. So we do have the detection of which cluster type you're targeting. And then internally, it's all through the template inside Helm that we have some logic, just basic if else and all that stuff inside. So we check for the version, and then if the cluster type is Minikube, well then we know that we need to do all of this. So some of the charts are actually doing more than just doing selector. They actually do create new resources that are totally different from the other cluster, obviously because there's some things that need to be done. That's the case for, let's say, secret management for certificates for the Ingress. So that we have one that is signed for Minikube for everybody, that's fine, that we can actually use, so we use it directly. The other one for GKE, you need to input the values. So there's some values are needed for some cluster and some are not.
How do you deal with namespaces and like cluster-wide resources with Helm and Tiller? And also, are you running like a single tiller, multiple tillers? Like, what is your permissioning model around that also?
Yeah, right now, I need to be honest, the permission and the RBAC and all that stuff for us is fairly simple. It's not something that we're pushing really hard. We do have the luxury of having one cluster per production, so there is not really a big need for segregating the namespaces explicitly because we have multi-tenancy. It will come. And what we're doing right now, we're running on a single tiler, and we did have a focus at one point where I was talking about the assembly. The assembly was actually one assembly per namespace, so we had only one release. Now we're going to change that and have more than that, but that's basically our usage right now.
With the introduction of the Helm Tiller plugin, do you see your usage of the assemblies changing at all? Do you see like the Terraform configuration being more of that holistic environment mapping? And could you also talk a little bit about how you manage the hierarchy of environment variables and the injection using that plugin?
Yeah, what we're doing, and by the way, the Terraform is not a plugin, it's actually a plugin for Terraform, so it's not a Helm plugin. But the way we're doing that, the way we're doing the, let's talk about the hierarchy of values, and that's one thing that I just contributed to the Helm provider. Basically, what we've noticed is that we're breaking up the assembly, and by breaking up the assembly, you have multiple charts that are targeted. So we have one cluster that is defined inside Terraform. Inside there, you have all the releases. So we've taken an approach where we're targeting releases instead of namespaces. So at first, we were targeting namespaces, saying, oh, that's a namespace, so we're going to do one release in it. Now we're saying, no, we're going to do multiple releases in multiple namespaces. Now the thing is that because you're in one cluster, most of the time we have some values that are cluster-wide, some values that are namespace-wide, some values that are service-wide, because sometimes a service will actually have multiple instances, but then they're sharing the same value except for the customization. And what we did is that Helm provides you with the fact that you can supply multiple value files. So we do have multiple value files. And I did integrate that into the Helm provider so we can actually do that. So we have now a common, let's say, cluster-wide value file that is all the values that are needed for the cluster for all the releases, all the charts. And then we have the same thing for namespace, and then you can go as granular as you want. So if a team wants to go and say, oh, for all my services, even though they're on different namespace, I could use the same value files and update that once. That was coming from a problem where, because we're using assemblies and because we have multiples and multiple information, we had these really big value files that were really hard to manage and really hard to say, okay, is that the right values? Did I put the right thing? And the worst case was when, oh, well, let's change the values because we're doing version 2. Now it becomes a nightmare because you can't do a diff and you don't know why. So that's why we have the multiple value files and the validator as well that will validate that you do input the values that are expected.
Can you say a little bit more about how you're doing the validation of your supplied values?
Yeah, I could try because I didn't write the code. I know I didn't oversee what they were doing. So what we're actually doing, we're taking the values that you have, then we're getting the chart and getting the values, the default values from the chart. Then we compare both of them, being the values that are coming from the chart, that we extracted from the chart, are treated as a schema. So we say these are the values that are expected. Then we can tell you all the values from your file, which one are meeting the expectation or not meeting the expectation, with the caveat that if you include YAML inside your YAML files, because you can do that inside the value files, well, these are excluded because we can't actually go and parse that. So it sort of solves a big part of the problem, but not the whole problem, because sometimes you could say, oh, I'm going to expand these values directly in my chart because I know how to do it. Well, we can't validate that anymore. But the rest is taken care of. So it's basically a comparison of two YAML files, and we do have like colorized information and what is missing and what is not missing, or what's hit or not hit. And we're considering open sourcing that as well eventually to make it so it becomes available for everybody.
I've been asking this for multiple vendors. We are just starting on the Terraform plus Helm combination, and we're very interested in the Helm provider. I'm assuming MCUA,
Yeah, M Quadros.
M Quadros, yeah, okay. But that has not been, I see the pull request has not been officially integrated into the
No.
Terraform providers. Do you have any idea?
Well, from what I've known so far is that he tried to do it. He made it as much as he could. But I don't think that Terraform was like really interested. I don't think they want to take as much as they can on all the providers now. They're sort of putting maybe a limit or a threshold on how many providers they want to support in their own distribution internally. So that's probably on the back burner right now. So it's something where it's not as prioritized as anything else.
Okay.
Also, it's probably going to be better once we hit a 1.0, because right now it's still in flux and there's still a lot of things that need to be changed. So I do have some new changes I want to propose to the provider, namely that right now it can't handle upgrade of Helm. And I wish it could do that, so I want to do a PR or actually open an issue saying, could we actually make Tyler a Terraform resource so that we can actually upgrade Tyler using Terraform instead of having what we have right now, which is sort of stuck in the, if you install it, it's fine. If you don't, well, it's up to you to change it. So.
Okay. So can we start using it, hoping that it'll...
It's getting better and better.
Okay.
It was like a big part of the last autumn. It wasn't updated or anything. There was some issue with concurrency with Tyler. Now it's been solved, and then we're pushing some new stuff. So I'm not a main contributor. I just contribute right now, but I'm trying to push the project a bit further because we're using it internally, and we want to make sure that it's as good as it can be. So I do have 1 or 2 PRs open right now to make new stuff come in.
Okay. Thank you very much. Thank you for the
Welcome.
effort.
I think that's pretty much it. I think so. Well, thank you for your time.